Moving right along, we have been talking about the polar coordinate system, and we're going to look at polar equations and graphs. So all the graphs discussed in this section, you can actually graph with your calculator, a graphing calculator, of course, under mode, graph, and polar. May not have been aware of that, but you actually can. All right, so remember what the rectangular grid looks like versus the polar grid. So an equation whose variables are polar coordinates would be called a polar equation. And then the graph of a polar equation consists of all those polar coordinates that satisfy the equation. So just the same as when we graph an equation, we say all the xy values have to actually correspond to that particular equation, and the same thing with polar. So if I look at a polar grid, again, these concentric circles are actually my radius. As you can see here, radius 1, then radius 3, radius 5. And then the rays, I start the vertices at the pole, so meaning start right here, which we're calling, what you're used to calling the origin. In this case, with polar coordinates, we're calling the pole. All right, let's do one of these. So if I get me a pencil, and I want to identify and graph this equation, r equals 3. Well now, what if I squared both sides? So in other words, remember that nice little algebra, you do something to one side, you have to do it to the other side. Now remember, I can actually find r squared based off of x squared plus y squared. And now this actually looks very, very, very familiar, right? X squared plus y squared looks like a circle. So as you can see, my x squared plus y squared equals 9 corresponds to r equals 3. So if I start right here and I go out 1, 2, 3, then I make my nice little circle. Good job. Thank you. All right, so if I have another one, I want to identify this graph. So I have theta equals pi over 4. What I'm going to do is I'm going to take the tangent of both sides. All right, crazy algebra stuff. Do something on one side. You got to do it to the other. Now, remember the tangent is the same thing as y over x. And what's the tangent of pi over 4? Do you know? Where's your unit circle? That's an easy one, because remember that's square root of 2 over 2 divided by square root of 2 over 2. So that equals 1. So if I solve this for y, I get y equals x, which is just simply the line y equals x. All right? And notice here that my angle, theta equals pi over 4. That's why you're seeing this piece right here. What if I want to identify the graph of this equation? Well, again, remembering things that I kind of sort of remember, that this is y. So this is just simply the horizontal line, y equals 2. Right here. So notice I went up from here, I went up 1, 2, and then I drew my straight line. I can do this, of course, with a vertical line because I remember that r cosine is the same as x. So in other words, this is the graph of the vertical line, x equals -3. Right here. All right, so this gives us this theorem now that says if I have some non-zero real number, then the graph of the r sine, which we just saw, is a horizontal line. And above the pole, if a is greater than 0, and below the pole if it's less than 0. And then the r cosine theta equals some value is my vertical line. All right, so let's try another one. I want to identify this graph, so let me just rewrite it again. 4 sine theta. What I'm going to do first is I'm going to multiply both sides by r. So I'm going to get r squared equals 4r sine theta. So that's all I did, was multiply both sides by r. And like you saw in that previous example, r squared is x squared plus y squared. And this would be 4y. All right, so I can kind of see there's something going on here with a circle, but I need to get this in the actual right form. So I'm going to move the 4y to the other side. So minus 4y equals 0. And now I need to figure this piece out. If it's a circle, then what I need to do is actually complete the square. That's what I'm going to do, is complete the square. But what I need to do is get it in the right form. So I'm not doing anything with the x squared, and I'll just kind of leave this in parentheses. So do you remember how to complete the square? No? Maybe? So remember, when you have a quadratic equation, ax squared plus bx plus c, and that's what I have, is you take the value on your variable with exponent of 1, and then you divide it by 2 and you square it, and you take that value and you add it to both sides. So as you can see, I have a negative 4 over 2 squared. So that gives me negative 2 squared, which gives me 4. So I'm going to add 4 to both sides. Done good. And the reason you do this whole completing the square, is so now you can factor. So I've made this a perfect square. So in other words, this becomes y squared minus 2, because of that minus right there, equals 4. So I know that this is a circle. It's again right here. And it's, let me write over here, it's centered at, well, there's nothing there, so 0 and 2, because remember our formula is minus, so we just take the 2. And then with a radius equal to the square root of 4, or 2. All right, looks good, looks good, looks good. So I can see what the graph looks like. All right, and so let me mention this. So in other words, I go up 1, 2, there's my center, and then notice I go 1, 2, up, 1, 2, down, and then I can draw my circle. All right, kind of works the same way with the cosine. I'm going to kind of go through a lot of the same steps. So I have r equals negative 2 cosine theta. Multiply both sides by r. Negative 2 cosine theta. And this becomes x squared plus y squared equals negative 2x. And so we just do the same thing, but now I'm going to do it with the x. So I move the 2x to this side, plus y squared equals 0. I complete the square, so 2 divided by 2. Oops, I was thinking of my answer already. So in other words, this becomes x squared plus 2x plus 1 plus y squared, and don't forget to add 1 to both sides. I can now factor this, x plus 1 squared. Did I put a square on that last slide? I don't remember. Let's go back and look. It's like I can't remember, did I? Ooh, and you were probably yelling at the screen, right? Bam! Teacher makes mistakes. Not good. All right, so at least I thought about it. And then plus y squared equals 1. So this is centered. That's a positive, so I need to make it a negative 1, 0, and with a radius of 1. Okay, so what does that look like? It look like that. So as you can kind of see, if I have this cosine or sine, And in fact, you can look at, let me just throw all these up here. You can see what's happening here is basically with a pattern is if I, and it's what you're used to with negatives where it flips it, right? And so it's either flipping it across the x-axis or flipping it across the y-axis. And which brings us to this theorem that every one of these equations would be a circle, and then based on the particular radius and then where it's actually centered. All right, so we'll continue on up next.